this mode and do the presentation this way?
I reckon that's the best way to do it.
Yeah.
Right, everyone. Thanks for coming. This is the November meetup, and welcome. Do we have any first timers here? That's quite a few people. Yeah, welcome. Just a bit about the group. We're a community-led AWS user group. So for people who like to nerd out on AWS and share their experiences, show our builds, all our presenters are usually from the community. So if you've recently finished a project or if you're really excited about something, come and share it. We try and cater from talks from beginner all the way up to advanced. And we're having lots of fun, I guess, sharing. So today we're going to hear from Ben about Kinesis, and then we're going to hear some updates of what we've been doing to continue that formalization structure that we're doing around the whole brand and the swag and the society. So I'm really excited to hear those updates. And then we're going to hear about a presentation about CDK, which is personally, I'm pretty keen on CDK. So bit of housekeeping, the bathroom's over there. If there's a fire, go over there and run outside. Don't go that way because it's more building over there. If there's an earthquake,
duck and cover.
Duck and cover like a turtle. All right. And that's about it. So first speaker is Ben. He's going to talk to us about IoT and agriculture and the use of Kinesis data streams. It's fire hose data streams. All right, one of those. Thanks, Ben.
Thanks.
Do you want a mic?
Can everyone hear me at the back all right?
Yeah.
You get me? Oh, yeah, I think I'll be all right. Yeah.
Sweet.
Awesome. Great. Get started. Cool. See if it works. Awesome. Right, my name is Ben Fellows, and thanks for having me today to talk about AgTech and AWS. And so what I'm going to touch on is my own experience, and I've got a bit of a backstory first. Lovely picture there of the farm. So my own story is that I've been doing AWS stuff for a while, but before that, way long ago, before I got into computers, I was in forestry and I was brought up in the rural sector, part of my life. And I've got this sort of connection with the land, I suppose. It's sort of a Kiwi thing. So I'm quite passionate about agriculture, but also there's lots of challenges in agriculture, and so there's a lot about climate change and sustainability and environmental and all this kind of cool stuff that's been sort of the good challenges to have. So there's some big problems to solve in agriculture at the moment. It's 48. So farming is 48% of GDP or exporting. So it's a big industry. That's a big industry globally. So the big problems to solve in agriculture and mainly for AgTech is reduce time to market for AgTech. So how can you build solutions that help customers and help farm companies and agricultural companies get to market faster? Provide AgTech companies with pre-built cloud platforms. So that's one of the problems I set out to solve. Enable sort of the API economy for a very traditional business. So one of the challenges with the AgTech is the data sharing, and that's not just about technology, it's actually about culture. So I think with a bit of cloud, you can change that. I think that opens it up so that you can innovate with various working groups in the ag industry. So if you can demonstrate something quite quickly, and AWS is a really good platform, and I'll sort of talk about why. If you can demonstrate really quickly to the ag industry, then you get a lot of buy-in for this kind of data sharing stuff. And build a cloud native platform. So, business value, all the typical cloudy blah blah stuff. These are just some of the feedback I've had from talking to different people or groups in the agriculture industry. So one of the challenges is we need better ways to communicate across the industry. Having to enter data multiple times, that's another big problem. Like most industries, I mean, you've always got that problem. I've just started using XYZ product, so I won't know the product. But talking to a farmer, they say it takes 7 steps just to put simple bits of information in. So some of the farming apps are really complex. Another thing, Rural Innovation Lab, so that's a sort of a lab that's been kicked off in the industry to help kick off some technology innovation. They're sort of staying, they haven't been really good at telling our side of the story. For me, the light bulb moment is that it's not all about technology. So you've got this big thing called the sustainability conundrum, that's what I call it. And so when we think about sustainability, sometimes we might just think of one area of it, but one aspect, but there's 3 parts to it. And trying to get these 3 things work together is very challenging, especially in the agriculture industry. Obviously got environment, economic and social. So one of the goals of any solution is just trying to think about those 3 aspects. Why use AWS? So help farmers make better decisions to become more sustainable, simplify data, ingestion, processing, storage and analytics, pay as you go, which is perfect for most industries, don't have big capital upfront expenses, IoT native support for census, build reliable data models and run experiments with data, so data science. So what are some of the challenges for ag tech around the IoT space? So integration, remoteness, there's no one size fits all approach. So as with some other industries, you can sort of apply the same, a common set of principles. With agriculture, there's a lot of challenges, and even like the sub industries like dairy, beef, sheep and lamb, and all these kind of different industries cropping, they all have different needs, and you can't just put a sensor in the ground. So we'll talk a little bit about sensors, but it's not just a matter of putting a sensor in the ground expecting it will, all of a sudden you've got data and it's going to be accurate or it's going to work and all this kind of stuff. So that's some of the challenges. Big challenge is where do you put sensors, and stock cow, especially big cows, they damage everything. Whatever they can find, posts, motorbikes, sensors, they'll trample on it, and you've got lots of mud. So that's another challenge. So what are some of the common sensors you use in the ag tech space? You use soil moisture, temperature, weather station, river quality, and water flow. That's some of the common ones. There's lots of other sort of use cases or types of sensors. So now we're just jumping into the meat of it. What does a sort of high-level ag tech platform look like? And so this is a very simplified view, but essentially the idea is that typically you'd have your farm, and then you'd have some sensors on your farm, and then those sensors, I talked about the challenge of remoteness before and integration. So lots of different sensor providers have their own sort of data formats, communication methods. So one common sort of communication link is radio. So whether it's LoDa or Sigfox, or there's lots of other different technologies. So what you need is an IoT gateway. So the IoT gateway connects to the internet and it talks to the sensor, so the sensors can send data up, aggregate it, and then forward packets from sensors up to the cloud. And so in an ideal world, this is an ideal solution, but it doesn't always work because one size doesn't fit all. So you have an IoT gateway. That could be a custom built device. So it could be built in Raspberry Pi, but you're probably better going and buying an industrial strength off-the-shelf application. Off-the-shelf device. And then you can use MQTT, HTTPS, ideal scenario. And then use AWSUG Core. And I'll talk about these different components in a minute. Typically what happens, however, is that not everything's ideal and no one size fits all. So quite often you've already got sensors on farms, and so you might have a sensor provider that's gone and built their own platform. So they might do some of these things already. So the idea is to be able to simplify getting data out. And one of the goals one of the common sort of threads, I suppose, is that a lot of sensor companies are focused on getting the data out and getting the data to the farmer, but they're not necessarily focused on. So one of the challenges is around, they're a sensor company, that's what they're really good at, but they're not necessarily going to give farmers the insights they need. So you need to build a bit of tech on top. So that's where the sort of right side and then all these other third-party applications can be plugged in and all this sort of stuff. So to make this sort of happen, I'll just go back, talk a little bit about AWS IoT Core. is, just to give you a brief overview, this is a breakdown of IoT core. You've got identity service, device gateway, message broker. So identity service is really about getting the devices, onboarding them, and getting them onto AWS platform pretty much. And so how you're going to authenticate, authorize, there's certificates, we use MQTT. So there's different approaches. Device gateway and message broker work together. That's sort of getting your messages up. So this is more the identity is what is the device, how's it going to communicate, let's get the device up. And then rules engine is around, so once you've got your IoT data in AWS, what are you going to do? What kind of rules are you going to have? So you can subscribe to what's called topics. So topics are essentially they're like keywords you can create. You can create loose topics, and the idea is that you can then send topics off to different services like Kinesis or DynamoDB, and you can store the data in S3. Device shadow is just a copy, so it can be a copy of a device at a point in time. So let's say, for example, you've got a sensor that shows you temperature, then you can go into see the device shadow and you'll see the current temperature. That's the idea anyway. But of course, you've got historical information as well, so you might want to use S3 or something to store that history, or DynamoDB or XYZ service. I talk much about registry. So yeah, I've talked a little bit about IoT device with gateway. So you either need direct connectivity or LoDAR or Sigfox connectivity. So you're either going to set up some kind of, just pretend it's an IoT gateway, and you've got a whole lot of sensors talking to it. You're going to have to choose a method for connectivity. Add a device. You can add a device via the AWS console or the SDK. Create certificates for the device, install certificates on the device, and set up a just local service, no queue. So typically, as I said before, you probably buy an IoT gateway, and it's to support radio and internet. So the next thing is, so I talked about the IoT rules. So an IoT rule can be created that basically sends data to Kinesis. So before let's say we're doing this manually in the AWS console, what you want to do is set up a Kinesis fire hose. You could set up other types of Kinesis or other, you could use DynamoDB, but in this case, I'm just using fire hose. And so I'm creating a new delivery stream. I've set it up, and I'm basically, these are just some of the configuration settings. And then the main one is set destination to S3 bucket. So you'll see over the right there, I've got a delivery stream called farm, and it's sending to a destination called team demo Kinesis. So then create data sets. So the idea is, what I talked about in the architecture before was you want to have, so this solution sort of is really basic DynamoDB. It stores a sensor ID, and it's got a key for the timestamp, and it's just got, you can store any amount of data in it you want. So it could be temperature, it could be soil moisture. And then there's an RDS database, so that's basically metadata about farms. So you can get a bit more intelligence, I suppose, around the metadata, just so you can link stuff up later for API calls or if you want to build an app. So now you've got those two things set up, you need to set up an IoT rule. So to set up an IoT rule, you can select I talked about a topic before. So essentially a topic is, what's a topic? It's basically a category, because that's a category or something. And so it's pretty loose. But what you can do here is use SQL to select the data you want from that topic. So let's say the soil moisture sensors, they might have an attribute called temperature. So you basically say, I want temperature and I want it to go into the S3 bucket. So it's sending a message to an Amazon Kinesis Firehose. And the previous screen, good, we said send that data to S3. So eventually it's going to get to S3. Cool. And then another thing you probably need is something like a Lambda function. So Lambda function, now there's lots of different ways to do this. So I've just decided that I'll put a Lambda function after the S3 bucket. So, but you could put the Lambda function, earlier in the steps. so it doesn't really matter too much. So just reiterating again, you've got this function here, and then so you've got stuff in S3 and then pulling stuff out. There's an S3 event, an event goes to Lambda, and then you've got data that gets stored in DynamoDB. And then so you could, so the API, essentially what the API is doing is pulling data, and then you could, if you're a third party or you want to do some further analytics in your AWS account, then you can go and build whatever you want, just pulling that data. So the key benefits for the farmer, so the thing about this sort of solution is they can answer what census it reached a threshold, so lower and upper percentiles, so 80% soil moisture or 20% soil moisture. That means a decision to irrigate or water their paddocks, or don't water your paddocks, or move stock or something else, or fertilise. What anomalies are in the data? So that's getting a bit more advanced, probably not so much for a farmer, but it's more for an agricultural or ag tech company. What are the latest sensor readings? What is aggregated data from farmer to I guess from a farmer's perspective, trying to reduce manual overhead. So one of the challenges with a farmer is that they hold a lot of knowledge in their brain, and one of the things they do is go like this every morning. Oh, it's all right, no wind, it's not going to rain, and then 20 minutes later it rains. Also, there you get a variance of weather, even in like microclimates. So even as in Wellington, it can be fine here. You go over to Wairarapa, but even in individual farms where they've got thousands of hectares, or they might have different bits of land. So if they want to sensor on each bit of land, because it might be raining outside their house, but up the road it's actually not raining. So just sort of things like that. And the reason I guess reducing manual overhead is about reducing the amount of people that are on the ground trying to do stuff manually, look at stuff manually, and they can get on with other stuff. So a big question is how much does it all cost? And so one of the things I had to do, because everything in these services is so micro cost. So if you have one sensor trying to price this thing, it comes out of zero. So I had to get 1,000 sensors and work out what would be the cost of this thing. And so you've got to have some considerations around what kind of data and how often you're going to set it up. So for farm data, it doesn't have to be real time. So it could be 15 minutes, it could be an hour. The reason for that is because you don't have to know that it's rained like 10 seconds ago, but it's important that it's rained an hour ago. And what you want to do with the intervals, maybe decrease them just so you get a bit more accuracy in the data. But essentially for a farmer, they're not going to be making a decision every 5 minutes. They're probably going to be making a decision every couple of days around, should I put some water on a paddock, or should I fertilise, or what should I move stock? Another consideration is how many sensors. And there's just to the right is some calculations. So it's very cheap to run this kind of solution on a farm. There's not the sensor cost and the setup cost, but this is like the ongoing cloud cost. So the raw cost is like $3 per month on average for a farmer, which is really cheap because they used to buy in like $200,000 tractors. So it's actually a drop in the ocean. There's definitely a lot of trade-offs and alternatives around the solution that I've built. There's lots of different ways of doing this, and I suppose that's one of the things with AWS, there's lots of services to pick and choose from. And so there's probably lots of areas where this could improve, but also what did I want out of this platform? And one of the things was it didn't need to be real time, so I didn't have to get data in straight away. So I would sort of sacrifice performance in that area. The data, I want it to be durable, so S3 is a good choice. Why Dynamo and RDS? So I decided that Dynamo was good for high volumes of sensor data, but RDS is good for just like measure data. And again, I could have used Dynamo, but I decided to use RDS. Why use Lambda? Because it's serverless, and Lambda's pretty cool at the moment. There's always improvements to be done. And just a little bit about IoT Core. Not one size fits all. So IoT Core was it's useful, but it's not necessarily always the right solution because, like I said on one of the previous slides, is there might be a sensor company that already does half the heavy lifting of the data, so you don't necessarily need to use IoT Core for that. That's pretty much. Feel free to ask any questions, probably 2 minutes, and then I'll.
I've been tinkering with this agriculture tech thing in the cloud. I bought a Veggie Hub. I don't know if you have read about it. It's an American device that actually you can put 4 sensors and it makes a post HTTPS to any API that you.
Nice.
And I managed to get the data in JSON to AWS and the transformation and all. I did the sort of the research around if IoT devices were or using IoT AWS was a better choice. This is a totally random device using an API gateway, basically. In your experience, what are the trade-offs of using a different device and using API gateway or using a device that is an AWS IoT certified or something like that?
Yeah, I think agriculture is really hard because you've got all these things like mud and stock, and so depending on the type of, it's very like soil moisture is very hard to measure, and soil moisture you have to buy quite expensive devices to get accurate readings. Yeah, I mean things for like weather stations as well, they're quite expensive to get accurate information. It's also yeah, my experience like any of the protocols are fine, but it's having a good IoT gateway as well. Yeah, on the farm. So you might have a whole lot of devices that are on the farm that are all different vendors. It's usually they're going to be they probably won't be AWS certified IoT core type solutions. They'll probably be more like out of the box vendor solutions. Yeah, just on a farm, but it'll probably change over time. Hopefully, yeah, because it'll be cheaper.
And in sorry, just to grab you just for a second, what's the biggest problem of them? What will be the top priority for them to know? Like, what information is the most useful for a farmer?
I think for dairy farmers, it's when should I when should I water my farm? Because water's the lifeblood of the farm. For cropping, I mean for other like fertilizer is really important as well. But you can't necessarily solve that with sensors all the time too. Like there's new sensors that come out now that measure the nitrogen and the nutrients in the soil, but they're not field tested enough. So that's one of the challenges. The other challenge is around compliance, so environmental compliance to councils. And there's a new device coming out that do like river quality checking, but they're still not field tested. So it's a big headache for farmers, but it's so complex. Soil moisture seems to be the easiest one for now, but I'm sure like there'll be lots of others here where they can solve. Yeah,
I have a soil moisture sensor.
Yeah,
it's sort of easy to. But yeah, there's so many things.
Yeah, there's like so many different variables to make a decision. Yeah.
You didn't think of, did you consider the likes of green grass? I think Amazon green grass.
Yes, yeah, definitely. I mean, that's something. So I didn't talk about that tonight as one of the possible solutions. I've got to talk about that. But one of the challenges with this is trying to find those trade-offs again. Like I mean, I haven't personally played with it myself anyway, but I think it could be it would require a vendor to pick up that technology, and I think make it really actual robust in some of the agriculture sector. Yeah, I think if someone may come up with a really good solution, it'll be great. Yeah.
Did you think of using Elasticsearch as a DynamoDB?
Yeah.
Can you repeat the question, please?
Oh, yeah. So you said, have I thought about using Elasticsearch instead of DynamoDB? Yeah, I was pretty lazy. I mean, I'm more familiar with DynamoDB. I haven't used Elasticsearch for a while. So it was just what I'm comfortable with. I think that's half the problem as well.
As your data becomes more, the footprint of the data becomes better, there must be other parties that would be very interested in this kind of data, local councils, NIWA.
Yeah.
Have you thought on selling the data?
Yeah, so what I want to do is I want to because I'm an open source company, so I want to open source this so that ag tech companies can innovate. So my role in it is that the ag tech companies that have been there for like 15, 20 years, even 5 years, the new startups that are really focused on this area, I want to give them some sort of platform, and they can sort of because I think they're still the ones with the most knowledge about it. You know what I mean? Like it's quite a hard industry it's like healthcare. It's sort of like you try to put your toes in it, but you try to stay away from it too much. Yeah. Even though it's an exciting area. Cool.
Cool, with that, thanks, Ben.
Awesome. Thank you very much.
So next up, we're going to hear some updates from the metrics we're kind of starting to track. But I thought I'd just jump in there first and mention that we are a non-profit company and we are now kind of looking more seriously about people to help sponsor. That's so we can make the events bigger, so we can get swag for everyone and basically just grow, I guess. So if you're a manager or if your manager has a sponsorship budget, we'd love to talk to you and tell you about all the benefits and the packages we can provide. So Gleedson is going to come over and tell us about metrics. What are we measuring?
Good question.
Okay.
What is the adapter thing? Oh, there it is.
You just moved the live stream.
Yeah.
Oh, okay.
I need. Yeah. No. That's a good idea. Yeah. I'll borrow yours if you're okay with that. Thank you. Okay, you come back here. Cool. Okay. Okay. Cool. Okay. So
many members.
Yep. So the first thing we will talk about is the number of memberships. Okay. So in the past 90 days, we got more than 100 new members to our group, right? And remembering that we have obviously a nationwide structure, but we are also broke down by cities, right? And the tracking we have here is the global, but only on the city of Wellington, right? We had like 3 events in 90 days, and obviously, if you're following us on Meetup, you'll be accompanied how many events we have posted so far. And a little more below, we can see how many members we have, and out of those, how many new members we had per day. So at least we have the minimum of 3 new members per day joining the group, okay? That's the first thing I want to mention here. The second thing I want to mention here is that some of you may know, some of you may not, but Meetup had some sort of restructure, and part of the restructure was the referral that from a certain date, all RSVPs to events must pay to participate, right? And the money obviously doesn't come to us, it goes straight to Meetup. So we are aware of the situation and we are doing what we can to make this free, even if this means switching platforms, right? Now, everyone here knows, and I hope that you on the stream knows as well, that we have other social media networks, and you can come to the website to see what they all are, like our Slack channel. We have a Slack channel. You can go to our website and get the invite to join our community and keep the discussion outside of the monthly meetups, okay? That's the second update. The third update is that we got new user groups ignited, right? This is us. This is the Wellington chapter, and this is our event today. But Oakland also got reignited, and they have an event this Thursday. right? And it's also a group of AWS users, but based in Oakland. But we also have a brand new Hamilton user group as well. And I'm not sure when they are meeting, but hopefully they're meeting soon. Yep, hopefully. And we also have a Christchurch user group as well. And as part of these, we are making sure that we can reach other cities so they can also ignite their own AWS community user groups. Okay, and my last update is that we are working on some swags. Okay, those are a few samples that we got. We are working to get others as well. And if you want to check what we are getting, you can come to the table of the pizza and check it out. We'll bring more updates about how we can give that, if you're going to give that, if you're going to sell that. You keep up here and you will know about that. And that's it. Thank you.
So let's just take a quick 5 break while we set up for Carson. So introduce yourself to each other or something.
But I'll watch the video.
So if you go
I'll do it. So I can see this thing.
Looks when they're using TypeScript.
It's good. Is he got a sponsorship budget?
I'm just asking.
Fix this up.
Yeah, it's a good time to approach. This is good time to take. No, it's 25 minutes.
Okay, so you need to get the thing of things to come and know that this was
You make it run
This resolution does 60.
just try it.
No, I tried.
I'll change the resolution on that.
And I get you can
Right, everyone, let's kick off. So for the next presentation, we've got Carson from Digital Transformation here to talk about Cloud Development Kit, which is a awesome new way of representing infrastructure and I guess more defining cloud applications. So I'm real keen to hear about it. I'll get out of the way.
Good, thanks, mate. So you guys can hear me, right? I don't need the microphone there. So, and first of all, sorry for the resolution, because if I go full screen, this thing a little bit getting ugly. So I will use this one. I think you guys can see this thing, right? Cool. So thanks for the AWSUG group giving us the opportunity to talk about this thing, because this is what we did last couple of months, and we thought we'd be glad to share our experience on this AWS CDK, which is Cloud Development Kit. I think this developer-centric infrastructure as code tool, that is my explanation of that one, and I call it next generation tool as well. So first of all, I'll tell who am I, because I'm don't worry about my second name. It's Kasun Jayasuriya, so it is hard to pronounce, I know. But if you're interested in cricket, you'll find it is easy, because that is famous Sana Jayasuriya is the name. So, but we are different when we're holding the bat. This is my contact details. I'll show that later as well. If you have any questions, if anything later you want to contact, either contact through DTL emails or DTL contacts or my personal contacts. So this is my agenda today, and I'm going to talk about infrastructure as code. Yeah, I know most of you guys know that, but I will get some entrance to the presentation in that, and then the real topics. IAC, I call infrastructure as code in serverless, and what CDK played in that the landscape. And then I'll tell you, because yes, I'm not just talking, we did something previously. We have done some case study to show you guys what we did using CDK, and then a couple of some basic concepts on CDK, and just show you the small demo. And then I will later I will open that demo project to the GitHub. You guys can start playing with that. It's a good start point, because that's the same demo I used to do a POC in DTL and educate the development team around the development. Finally, I will spend last couple of minutes to talk about the pros and cons of this thing. What is our learning, and what is our conclusion on this one? It is just a full opinionated to us, right? So this is my plan. So I'll try to fit this thing in the time I got, because it's a session I did in 45 minutes in DTL. So very quick, infrastructure as code. So I think most of you guys might know these tools set previously, because this is before that cloud era. So if there's new guys has come to the software engineering field recently, fresh graduates, so there's just for information, previously in software companies, there's some sacred place called server room, and you had some machines there lighting up. So then virtualization, after virtualization, you use these kind of tools. Before cloud, IAC was there, using tools like Vagrant, Chef, Puppet,
you scripted your infrastructure because of the virtualization. The main two things to me, IAC is important because of two things. First, the versioning, because you version everything that you do. You don't need to call the admin the midnight saying, where's the IP address you saved or where you have written down. So everything is version and source controlled, and the other things are important. It doesn't matter how much time you run that you get the same results, right? So if you're using IAC in your infrastructure, those benefits you get, and even before the cloud, these things were existed. And then the public cloud came, and everyone exposed their resources to the cloud, and you can call a web service, or maybe using the SDKs, you can create the infrastructure or the network resources, server resources in their cloud. But each cloud provider had their different APIs and different mechanisms. So there's a consortium called OpenStack. Sometimes back, if you have heard, they try to make it common, but it never worked. I work on project sometimes back, but I didn't hear that much from OpenStack. What happens? Every cloud provider has a different API. That is, story starts from there. Previously, it is your server farm and you script it in the way that the tools define, but now it's a common API exposed to the public. Then there's SDKs, because if you don't like to deal with the bare metal of HTTP, and then the SDK comes up with nice classes and functions you can deal with, you encapsulate the complexities of TTP, but it does the same thing. It creates the resources in the cloud. So then SDKs, then people who does not like programming, okay, I want to use this as a declarative mechanism. And then comes the cloud formation using YAML or JSON approach, like you maintain a configuration file. Instead of imperative approach, you maintain the infrastructure as code as some sort of YAML or JSON. It gives some additional thing as well, this cloud formation. I'll come back to that. But when it comes to outside AWS, there's something we use, something called Terraform. I think most of you guys know that. It is another open source common tool for the infrastructure as code, because using the Terraform, you can either use AWS or Azure or Google, doesn't matter, same syntax, something called HCL, HashiCorp configuration language. And it is, this is our opinion, because when we want to use CloudFormation or Terraform in our teams, most of the time, none hand goes for the CloudFormation, because therefore most of them we use Terraform, and it's our will. And it's another tool, but it is, you can, if you know the syntax, you can use for any of the clouds that they support. So this is how the stack goes up: web APIs, and then the SDKs, then the declarative form, right? So, and then here comes the SDK. The thing is, sorry, the CDK about Terraform. So again, it's instead of having the declarative form, you have another coding, a programmatic approach to define your infrastructure. So you might think, why not? Because previously we had the SDK written in all the famous languages, Python, Java, .NET, but why again CDK? The thing is that the SDKs does not maintain this feature called state, right? Using state only, that you can maintain that feature of idempotency, right? Or that means it is the key thing, because if you use SDK to write your infrastructure, then you have to write your own code to maintain the state. Simple thing is that assume that you create 2 servers in your cloud, and if you run the same script again, it will try to create another 2 servers. But if it is some uniqueness or something there, it will fail. But with the state, that your infrastructure as code, no, okay, this is already created, so I don't need to create this now. I will only create the delta if there's delta, right? Likewise, the CloudFormation and Terraform, in addition to that declarative approach, they maintain the state. That is why people use that over SDKs, because SDKs you have to use your own state management. But the problem was, people like us, me especially, coming from software background, always didn't like that much the declarative forms, and we wanted things to be done in a programmatic approach. So, and then if you have worked with CloudFormation, you might know that is how hard it is to deal with. When it comes lots of copy-paste, modularizing is not that much. But with Terraform, modularizing is there, but it is with the paid subscription, it is not that cheap, right? So CDK brings the state, plus it brings the programmatic approach to the infrastructure as code. So people come into the upside from the software background, so people like me love that thing. So I will come to other details later, but that is how I differentiate basically the cloud Terraform, CloudFormation, and AWS CDK. That's a basic difference. Right? And then to us, we use Terraform. It was very happy days. our ops teams use Terraform for the server containerized environments, server-side environments, no issues. But when we started serverless development, we started by this time we have done 3 or 4 serverless projects. So every time, but we had some sort of bridging problem because we use Terraform, but the Terraform support for the Lambda was not that great, right? So we had to always use, from the developer's point of view, some framework or serverless or SAM or something to use for the Lambdas, but our infrastructure, which is already created, was in Terraform. So if you want to get this practice, we had to have some bridge in between, because first your infrastructure is in the general infrastructure is in the Terraform code, the ops team runs that, and then the security groups and then some sort of common stuff, you have to, those configurations you have to bring back to the serverless or the SAM code. Again, it is another form of cloud formation. So either you have to manually configure those things, or you have to write a script. The Srinika tried to do the ops, the person tried to write a couple of scripts to do this thing, bridging. But it is not a nice way of doing that. Plus, and because it adds some manual stuff, we didn't. It's not that healthy. So we were looking for some problems. We thought of writing our own wrappers to the Terraform because we didn't want to change Terraform to CloudFormation. So, but then a few months ago, there was a nice session conducted by AWS in Max Brew. Some solution architect from AWS talked about CDK, and it solves these 3 things that we were always, as the architect, because I'm looking at the software side and the ops side of my company. I wanted to get both infrastructure and the source code, the normal application code, in the same practices, same design principles, same practices, same coding standards. But it was a little bit hard because we are using a couple of different tools and different languages. So this thing, CDK, it seems like, okay, this is a nice answer to our question. It's a single IAC framework that you can use for both infrastructure and the Lambda, the serverless stuff. And it is developer friendly. And previously in our team, if you won't write Terraform or some sort of the infra code, only myself and Srinika, a few guys like to do that, others didn't like because they're developers. But when it comes to CDK, now not only us, there are all other people writing infrastructure code because it is TypeScript. Everyone knows TypeScript in our teams because JavaScript and TypeScript knowledge is there with all developers. And it's solves another problem. And then if you are following that, because in that case, we are following the same coding standards, same styling and everything. When it comes as a development team, it is very easy to manage. And the third thing, no manual bridging needed between the infrastructure and the serverless projects. And if you like CloudFormation and serverless or SAM, it's not a problem. But for us, that was a problem. So if we talk a little bit about concept, okay, I talked why we picked CDK, what are the benefits that it brought to us. Basically, it is not a complicated framework. It is a very simple, structured framework. It has 3 things, basically: apps, stacks, and constructs, right? So app, I talked the AWS explanation for this one. App is the root. If it is an inverted tree, it is the top level, highest level component that framework knows, right? And then the stack is the unit of deployment that you're doing. That means you can group together and you can treat as one unit of deployment. I will explain that with our architecture. And then the construct is your normal resource level reusable components that you can build as classes or the functions, and then put into one stack and then put into one application. What this framework does is, because once you define the app and you give the app to the framework gets that app, the CDK framework, and convert it into a CloudFormation stack. So no CloudFormation involvement. As humans, you don't need to involve with CloudFormation YAML from there onwards. AWS take care of that, and from there onwards, AWS runs the CloudFormation. So this is the simple thing: apps, stacks, and constructs. App is the highest, construct is the lower level component. So yes, I'm talking theory. We have used that. Yes, we did. Last 3 months, because that was the best timing to us, because we finished one serverless project and we were starting another product development internally. So in that case, client is us, so we took the risk. And we use a CDK, some product called Piglet. Because we are developing some budgeting tool. Yes, there are plenty of budgeting tools, but it's a kind of an next-gen tool that has multiple streams to record your expenses. So with this full serverless project, and we thought of using, because this is some dashboard, just to show, yeah, I'm not lying, we have some real product. And so at the moment, it is in next 2 weeks, it will go to beta, and at the moment it is in alpha. So we use this, took the challenge and did a POC, and that is the same POC I'm going to share today, and use this as the, it's a kind of a challenge to us, but our management team supports us to take in the risk. And this is the architecture of the project. So I will use this architecture to explain the app stacks and the constructs, how we model that. So in this case, it is start from, it has multiple streams to capture the expenses. It has chatbots using Lex, and it has using Slack, Facebook, and those things. And it has Alexa, that you can talk to Alexa skill and record expense and set budgets. And then it has a customer portal, and it has a mobile app that you can scan receipts and make that into expense automatically, right? So we use text tracks for that. And then for the Alexa skill, it is Alexa skill again serverless. And then the hosting for our portal, it is again the CloudFront and the static hosting using S3. And for the receipts, again, the S3 bucket and the text track. Storage, DynamoDB, and then the CloudWatch to Datadog and the Grafana. This is the architecture. So Grafana and Datadog is already there, that we're using that. But everything else that we have to, this is a full from the scratch greenfield development. So what happens is the development team either commit the infrastructure code or the application code, doesn't matter. The Jenkins picked up and it runs the CDK, it runs the deployments, the application builds, and then push into the environment that we want. So, and in this architecture, everything is written in TypeScript, even the infrastructure code and then the application code, except the text track. Text track we written in Python because TypeScript is not supported at that point, and we implemented that using Python, but use the CDK TypeScript to compile that code and push into the AWS. Right? So this is the architecture. So I think you got the big picture of this product suite, and this is how the whole flow, CI/CD. So the same thing I discussed. So if I bring back the CDK knowledge that I presented a few minutes ago, this is how we have stacked. So the app is the piglet, so that is the highest level component, right? And then we have 4 stacks, basically. The base account infrastructure is provided by the reusable stack provided by DevOps teams, and it has the CloudTrail, generic CloudTrail rules, config rules, and WAF rules. But you see those are the construct in that stack. But you see that dotted line because these two config and the WAF still in the development stage on CDK. So we are not fully using that features missing at the moment. But everything else are in stable releases we are using. So this base account stack, which is written as NPM module, the ops team has written that any project that we are developing from moving forward, we are using that stack as the baseline. And then we have our APIs. We put that as a microservice stack, and all the APIs goes through that combine into a microservice stack. It will up to you, because if you want to have a separate stack to microservice, you can have your own. But the reason, this is how we have divided our model, because we can deploy each single stack or all together or multiple, right? So this is how our deployment unit, and then we have the receipt scanner the application stack, and that is written in Python. We treat it as separate one because it has separate things that is not common to the other ones. And finally, we have the portal, that is the S3 and CloudFront hosted stuff, and everything is written in CDK. And the nice thing is, in this case, not only the ops team had to write the infra code, or the development team, while they're developing the feature. Simple example: the developer developed the expense microservice, wrote the infra code as well, because both are TypeScript, right? That is the biggest advantage, because we didn't have, because our ops team is a small one compared to the development team. It didn't have the blocking tasks until and the workload is distributed. That's a big advantage. And the coding already shared. That means practices are shared, and I don't need to set up a new standard because it's not a new language. It's already there. So I think you got the concept, how it is divided to the same architecture I explained. So if I show you a little bit of the code, and again, a little bit technical, this is the code for the app. So I'm only showing two microservices here. Sorry, two stacks here. It has a base and the other one is cut down. So what you do in an app, you just define the instance of the CDK framework, and then you define your environment where you want to deploy this one, account and the region, and then you list down your app, the stacks, right? When it comes to stacks, again, three things: parent, props, and the construct, right? I'll explain that, because when it comes to a stack, you have to extend the base class of stack. Sorry for the resolution here. The base class stack from the framework, and it has major part of all the components in CDK is the constructor. That is the only public method that CDK framework knows. It is what it executes. Doesn't matter how many public methods you write, unless you code in the constructor. So in the constructor, you define your app. You have to pass your app to the stack. That is how the relationship is made. Because the root element you pass to the next stack, and the stack needs to be passed to the construct. That is how it goes. So the other thing is props. If you won't pass anything else, like usual, use that common data kitchen sink data structures, right? Props or the context or whatever you call it, you pass it to the constructor, because you pass everything else, all the garbage that you need to pass to that one using that props. And then name, you can name it the name to identify the CloudFormation stack. The constructor, it is the main method, and you have to write your all. If it is a stack, you have to write your all constructs in that stack. So that is how it comes to app comes to the stack, then stack goes to the construct, and then it creates the resources. So same concept in the construct. You have to extend the class construct from the framework, and parent constructor props and the constructor. Constructor is the only public method. You write your code, and the parent is the stack in this case. You have to pass the stack, right? And the props, again, the kitchen sink data structure. So and I thought, because that is related to the Piglet development, Piglet architecture, but I will show some the code that you can play around once I put the GitHub link to this event. I will do that after maybe tomorrow. And this is the simplified version of that architecture I explained. This is the POC that I did before I embraced this technology. So we had an API exposed through Lambda, to API gateway, and the custom domain, and the authenticator. It is not shown here. And then a DynamoDB database, and then some roles, then the CloudWatch and everything. So the code here, so everything starts in this story in here. Sorry. This is the starting point of this, because this is a TypeScript. If you started as a TypeScript project, this is how the structure looks like. It creates some boilerplate structure for you, and you have, this is your application code, and this is your info code. That is a convention we use. And when it comes to the framework, this is the main point. So this is the main command that framework uses. Since it is TypeScript 1, we have to transpile TypeScript in JavaScript. And then this is your app, and this is the main code, as I shown previously. And when it comes to microservices, and this is the same thing as I mentioned, shown you there. And then the microservice, this is the stack, and the real detail comes when you go to the real construct. This is where you develop your AWS level resources. You do your Dynamo table there, and you do your authorizers there, and you do your REST APIs, and then your Lambdas here. You see you're creating a new Lambda function. These are support utility methods that we have written, wrapping that. That is why the reusability is at its best, because you can have, since this is a general purpose program language, you can use your old practices that you use there. And the other thing, the biggest thing I like when it comes to the CDK, it has some feature called sensitive defaults. Right? If you have ever worked with the CloudFormation or the Terraform, and if you want to create something, you have to know the default, and you have to write those defaults again. Right? But simple example, the policy. In here, I'm giving this Lambda the access to this DynamoDB table. I'm giving the read-only access, sorry, full access because this is a post, the right? Previously, just since you're lazy, sometimes because you don't want to get all right, what you do, you create a power user admin, power admin role for the Lambda, and you assign that role to Lambda because you're safe, right? But now you don't need to find out what you need, but from programmatically using this the classes, you can say, okay, DynamoDB table grant full access to this Lambda. So it will reduce a huge amount of code that you have to copy paste or you have to use previously with Terraform or the CloudFormation. That is the best part of this framework. And this is one example. There are several things. If you create a VPC, you create a VPC with two public network, public subnets, two private subnets, and then the gateway, net gateway, and everything. Previously, you had to write some code to each element, right? So, and you can play around with this code because this is in open GitHub. I will share the link. And then if so just to show you these, all the things, I'm not lying, everything is created in the AWS. If you run this, okay, while it is loading, I will show you how it looks like when you write. So, not that packaging. So this is the basic command, CDK, and then these are the commands, synth, diff, deploy, destroy. Those are the base 4 commands if you are using CLI, right? Synth is if you can't forget CloudFormation, if you want to see the CloudFormation, write CDK synth and you see the CloudFormation, right? And the diff is something that it shows you what is the current state of, what is the difference between your code state and the cloud state. It shows you what's the diff, what's going to run the next time when you run the deploy. As deploy, it deploys your resources, create the resources, or update the resources in your cloud based on the code that you have in your local. And then the destroy, it tells it destroy entire stack. So that is what I was saying. This is the unit of the deployment because you deploy a stack, not the app. Right? So you have to stack your deployment. It depends on your boundaries. You define, okay, this is my stack. This is what I want to deploy individually as the entire infrastructure, or it's up to you. And those are the basic things. That is what I'm telling you, that is not a complicated environment. So I will just run synth just to show you this is the same CloudFormation. So if you run synth, it will dump you the entire CloudFormation stack. And if you still with the hardcore love with CloudFormation, go and see, oh, everything is fine, not like, right? And I'm not going to show you the command until it comes up. So yes, I was talking about the positive side of that thing. It has some these cons as well. Our experience last few months, yes, overall we are really happy because to me, especially the coding and the discipline that the people and the work distribution, because everyone now can write infrastructure code. And the thing is, general purpose language, as a developer, if you're infra guy, you might not like that, but as a developer with the developer background, I like the general purpose language. Doesn't matter what sort of programming, I like the general purpose language to use all the features of general purpose language. And as I mentioned, we love sensible defaults because sensible defaults save lots of time and lots of reading through the great AWS documentation sometimes. And then the ability to build the reusable libraries. Previously, that's one of the major problems we had with Terraform, because Terraform subscription is really expensive. And if you want modules, but with this thing, modules come free. If you can run a TypeScript library, and if you have NPM registry by yourself, you can push that to NPM registry and reuse that libraries, right? So those are the basic 3 pros I see in CDK. And the cons, since it is kind of still in the very early stages, and serverless side, most things are stable. But when it comes to other things, because the ops team is not a big fan, when it comes, there's still a few things are not that stable. So make sure that everything you want is working there. And the other thing is, I have plenty of bugs, and the documentation, it seems like auto-generated, but not some examples are not that great. So those are, when compared to the pros, for our project, because serverless one, we can stay okay, we can step aside from those things. Overall, we are really happy with that one. But before you use, just make sure that all the modules that you want is available, not in beta stage. Beta stage means every week they do a breaking change, right? So that means be aware of that one. So I took another 5 minutes, then I take. So that's conclude my session. So if you have any questions, time to raise it, please take 2 minutes. Otherwise, you can meet me.
Yeah, maybe we've actually got some pizza turned up, so maybe you want to take questions at
That's good.
pizza or anyone now? Go for it.
Cool.
It's a very interesting topic. I was just wondering, have you got experience of writing the custom resources when you do the CDK? Because I know there's quite a lot of services that are not fully covered for all the features configured in the automation.
Yeah. So yeah, a few things, because when other thing that I didn't, since he asked this question, if I repeat the question, he's asking, in addition to, correct me if I'm wrong, right? In addition to the inbuilt resources in the CloudFormation, have you written any custom things that is not supported by CDK, right? So simple example, when other good thing is CloudFormation, sorry, CDK, assume that you don't have a class in the CDK for that. They have provided some other class called CFN classes, right? In that case, you do is, yeah, it's kind of trick. And you can write your this CloudFormation things and wrap around if the CloudFormation is available, and you can integrate to the CDK. You don't need to maintain a separate CloudFormation stack. That is one way, right? So if it is not available as a CDK class, you can write you can get the CFN class and you can inject your CloudFormation attributes and you can use it. Still, the state will be maintained. That is one way. The other way that they have given some, we haven't used that, something called, I can't remember the exact name, some hatch thing, can't remember the exact name. In there, you can use that to customize, but the level of customization we went in is the CFN classes. If there's no CFN class, that means in that case, it is a little bit hard because that you can't maintain the state. At least you should have a CFN class, because then the state management is done by CloudFormation. Most of the services has, what they do is they first write the CFN classes, and then on top of that, they write their library classes.
One of the pain points when I'm using CloudFormation is that some resources it has to implement in the custom resource.
Yeah.
The state is not easy to capture.
If you go to that level, it is hard. So always we try to, that is what I was telling, wait until they at least release the CFN. If it is not, that is not the best to use the CDK. Fortunately, for the serverless and the landscape that we are using, in addition, because only the config and the WAF at the moment does not have that feature. That is why we're waiting. At the moment, still we are using Terraform and outside, but we don't go to maintain state because it's a reinventing on, it's a hassle. Thank you. Any other question?
How do you find the exception handling? You get enough features in the exception, or you have to get in the console to find out what actually there is?
So when you, it is normal when it comes to once you run the deploy stack, it is CloudFormation. So all the CloudFormation error details comes to the console. But most of the time, if it fails, we know where it goes because from the syntax and if it's a compile failure, the TypeScript tells us. But if it is the deployment level failure, we have to rely on the CloudFormation.
You get the details in the exception itself, or you actually always going to find out?
Most of the time, when you're running, we find out from the console. So sometimes we catch the thing and we write our own. So if you want to do that, but most of the time it is failing from the console.
Firstly, thanks for the presentation. Questions around how do you handle or even suggest we should handle the resource names? Sometimes I've seen when you generate and simplify the resource names are quite randomized.
Yeah.
Is there a pattern we should follow, or do you think it's just
Yes, good question. So the question is, when I show you that there's a, when it comes to stacks or the construct, there's a field called name, right? That is where you pass the cloud from the name for that resource. He's asking how you manage that, because when you dump that, the cloud formation creates some random name, right? Our way of handling, we don't care that. We only care the class names, right? Because we have the practices to maintain the classes because we don't worry about the cloud formation. So it is random. Most of the time, it prefixes something, but we only, so it suffix some stuff from the cloud formation, but we only worry about the first part. And we know, okay, this is the stack, this is the construct, and this is the, we identify from there. So we are not that much worried from the generation. We only worry about how you maintain your consistency in the class naming and the function naming.
If we try to customize that, you think that internally is used as like sort of a state reference?
We haven't come across because we always state we give it to the cloud formation. We don't worry about that one because that is the main thing we are getting from the CDK. So we leave that to them. So there's nothing. I'll wind up, and you can still after that drinks. You can come to me and talk to me if you have a question. If I know and if I can answer your question, I will. And again, thank you very much for.
Can we find that online? You mentioned a GitHub.
I will put that to tomorrow.
Okay, so maybe we can send that around at Slack.
Yeah.
The link to the GitHub.
Yeah.
That's really cool. So thanks again to presenters today. We've got pizza and drinks out in the hub. So thanks for coming. And again, just a quick shout. We're getting serious about event sponsorship. So if we want to make this bigger and do different types of events, then we need a bit of help. So keep that in mind while you're enjoying sponsored pizza. Thank you.
Thank you.
Hey, how are you? Yeah, I just came back.